This is June07, question 7. Figure 7.1 shows a junction point P in an electric circuit. The currents of 3 of the wires are as shown. Deduce the magnitude and direction of the current in wire X. So this is really an example of Kirchhoff's first law, where you are adding the total current going into a junction and the total current making that equal to the total current coming out. So the junction we're interested in here is P, and we can see that we've got 5 and 3 coming in there, and this 2 is going out. So we've got a total in, I shouldn't write R, I should write I, in is equal to 5 plus 3 gives you 8 amps, and at the minute we only have got 2 amps coming out. So to balance that up, to have the total current coming out as the total current coming in, we have to have 2 plus 6, and it has to go out that way. And so the magnitude of the current is 6, and its direction is from P to X. So you have to tick the P to X box there. In solving part 1, you use the law called Kirchhoff's first law. This law is often stated to be equivalent to the principle of conservation of charge. Yet in A part 1, you used the law to solve a problem about currents. State the relationship between current and charge that allowed you to do this. So the relationship that we use all the time is that charge is equal to current by time. And that is enough to get you your marks. You could write it out properly that charge is equal to current by time. You could also have obviously have written it as I is equal to Q over T. Right, the next part of the question then. So the next part of the question, part B, just scanning a wee bit again. Figure 7.2 shows a circuit in which a battery is connected to a resistance network. And so you can see here that you've got 2 variable resistors, R2 and R3. R1 is fixed. The battery has negligible internal resistance, so we can just ignore our internal resistance there. Use the words increases, decreases, stays the same to complete the following statement. So statement 1, if only R3 increases, the potential difference between the points X and Y. So we have to say what happens to it. So between X and Y, if R3 is the only one that increases, it doesn't matter what you have in here. Whatever you have across the battery is what should be across X and Y, and therefore it's not going to change, so it's going to stay the same. So our first answer for part 1, potential difference is going to stay the same. Okay, and then if only R2 increases, the potential difference between the points X and Y. Now, if R2 increases, we're now talking about not what's across the entire branch, but what's across only this part of the circuit. So even though these things here might change, the total voltage across here should be the same, but the ratios of how the total voltage splits up may change depending on the resistors in each part of the circuit. So we're going to consider what happens if R2 increases. So if R2 increases, that means that the total resistance of the parallel part is also going to increase, naturally enough. And if this increases, then the ratio of this to this is going to be a little bit bigger, and therefore the potential difference across these points, since V is equal to IR, then V should be bigger across this part as well. So the potential difference between X and Y should increase. If only R3 increases, the current through R2. So if R3 increases, then the total resistance in the entire circuit is going to go up. You have a certain amount of voltage from the battery, and V is equal to IR. So if R is going to go up, then I must go down in order that IR is equal to V. So the total current through the circuit is going to go down, and therefore the total current through R2 is also going to go down, and so it's going to decrease. So we're just going to write all that down for B part 1, 3. So as R3 increases, I is less, oh sorry, I'll just finish that off. As R3 increases, RT in the whole circuit so then the current is less in the main circuit, and therefore the current is less in the branches, i.e. through R2. And that gets you your 3 marks.